These units and symbols for electrical quantities will become very important to know as we begin to explore the relationship between them in electric circuits. The first and perhaps most important relationship between current, voltage, and resistance is called Ohm's law, discovered by George Simon Ohm and published in his 1827 paper, The Galvanic Circuit Investigated Mathematically. Ohm's principal discovery was that the amount of electric current through a metal conductor in a circuit is directly proportional to the voltage impressed across it for any given temperature. Also, the current is inversely proportional to the resistance of the wire or the resistance of the circuit. Ohm expressed his discovery in the form of a simple equation describing how a voltage, current, and resistance relate. And he did it with this mathematical equation, which is the voltage is equal to the current times the resistance in the circuit. In this algebraic expression, voltage, or the EMF, is equal to the current I multiplied by the resistance R. Using algebraic techniques, we can manipulate this equation into two variations, solving for I and for R respectively. This is referred to as Ohm's law, and this is probably the simplest and most important relationship in any and all electric circuits. Let's look at an example. A lamp or a light bulb, which we'll call the load, is connected across a battery. Given a load of 3 ohms connected to a 12-volt battery, what is the current that will flow? It is predicted by Ohm's law. The current will be equal to the voltage divided by the resistance, or 12 divided by 3, which results in 4 amps. Ohm's law is a very simple and useful tool for analyzing electric circuits. It is used so often in the study of electricity and electronics that it needs to be committed to memory by the serious student. For those of you who are not yet comfortable with algebra, there's a trick to remembering how to solve Ohm's law for any quantity given the other two. First, arrange the letters E, I, and R in this triangle. Then remember that V is always in the numerator, and depending on whether you're looking for the current or the resistor, one of them will be in the denominator. Or another trick is to think logically about current. Current will go up if the voltage applied is higher, and if the resistance is higher, then the current will go down. Another way to remember is by visually remembering this cartoon. You can see Mr. Ohm is restricting the entrance for Mr. Amp to come through that narrow opening, and Mr. Volt is pushing at the rear to get Mr. Amp through. Stay tuned to this site, as I'll be diving into more information on electrical installations. In the meantime, take advantage of the availability of my 50-page electrical power crib sheets. If you haven't already downloaded them, just simply fill out the information requested when you go to this website, https:// bit.ly/47 uppercase Y uppercase B 3 lowercase v and lowercase h. As I said, stay tuned for future releases on this site that will be providing you with more on my courses. You can also directly access my StanStore courses at this website, https:// lowercase stan.store/uppercase G, uppercase V, and uppercase B.